Today's daily dose of math is how to graph the inverse of a linear function. There are two different ways that I'm going to show you how to do this, and one of them is I'm going to graph it and then I'm going to graph its reflection. So graphing this line to start with, I have a y-intercept of -2 and I have a slope of 1.5, and that is going to make the line go across the point 4/3, 0. So I have my line. Then I want to graph the line y equals x, which is a line that makes a 45-degree angle with both axes. And I'm going to graph it with a dotted line because it's really not part of my answer. Then I'm going to graph the reflection of this original line, and I'll graph it in a different color. The reflection would go across the point 0 4/3 and go across the point -2, 0. So drawing a line through that allows me to draw a pretty good reflection of my original line. The inverse of a function always looks like the reflection across the line y equals x of the original. So you can see this as being a bit of a shortcut for graphing the inverse of a linear function. Whether that's going to get you full marks on a question will really depend on how the question is asked. If the question is just giving you marks for whether the graph looks good, then this could be enough. I think it might be best to label the line though, and since I don't know its equation, I could just label it as the inverse, and then label the original line with its equation because I know it. But the question might be asked in a way where you need to show the equation of the inverse function, and the way to get that is the other method for finding the inverse of a linear function and graphing it, and that is reverse the positions of the x and the y, and then isolate the y in the new equation. I'm going to start by writing this equation backwards, which you can always do in algebra. Then I'm going to move the 2 to the other side, where it becomes positive, and then I'm going to divide everything by 1.5. To cancel here, to isolate my y, I end up with y equals 2/3 x plus 4/3. And now it's easy to see that the y-intercept of this is 4/3, and that means I put my y-intercept in the right place when I drew this. Graphing this I don't have to show because it's already there. If we use our usual methods of graphing, whether we want to use the rise over run trick or making a table of values, we're going to end up with this line. So there's two different ways that I've shown here of graphing the inverse of a linear function. This way finds the equation. So if that's worth marks, you need to do it this way. And this way, this trick of drawing the original and then drawing the reflection across y equals x will always work as well with any function. This is today's daily dose of math. Don't forget to like this video and click on the subscribe button if you're not already a subscriber.